Okay, biology problem in geometry. You know you love it. Okay, the estimated number of species on Earth has been declining in recent decades. One of many models for this is the equation y equals 5 minus 0.025x, where x is the number of years after 1980 and y is the number of species in millions. Okay, I'm just going to write this. I'm just going to add this in here so that you see this. This is the years after 1980. That's what the x represents. The y represents the species, okay? So just so you can keep that kind of front and center here when we're answering these questions. It says, how many species were there in 1980? Well, how many years had passed after 1980? I hope you can see that that's 0 years, right? So if you want to do this algebraically, it's pretty straightforward. You just say y equals 5 minus 0.025 times 0, because we're plugging a 0 into the x spot, okay? So if you take 0 times 0.025, you can see, I hope, that there were 5, and remember, this is in millions, right? Okay, in millions, you see that? Okay, so how many species were there in 1980? There were 5 million, okay? So by the way, if you were graphing that, that's like the beginning. This is where the y-intercept would be, the 5. It's in a little different location because this isn't quite in slope-intercept form. You see the slope, the rise over the run, is in the back with the x, and then 5 is up front here, but it's the same idea. Okay, it says predict the number of species in the year 2000 for letter B. Oh, 2100. Oh, goodness. Okay, so from 1980 to 2000 was 20 years. So then from 2000 to 2100, that's 120 years. I hope you can see that, 120 years as x, okay? Because remember, x is the number of years. So when we're solving that one, we say y is equal to 5 minus 0.025 times 120 years. And that's what's going to give us our number of species. When you solve all of that, I'm thinking you should end up with 2 million. Don't forget your y value, whatever your y value is, it's going to be in millions. So we still have to add the millions there, right? Okay, the last one. How many species are expected to become extinct in a 10-year period? Okay, according to this model. All right, so what I want you to kind of recognize, there's a couple of things going on here. This is how fast it's happening, right? Okay, and the negative obviously means that the idea with the negative is that it's declining, the species are becoming extinct. So I'm thinking that the best way for you to think about this is if you take 0.025, right? Because that's your coefficient. X is the number of years, so we plug a 10 in here, and that gives us 0.25, okay? So that's 0.25 million. Now, I know what you're thinking. Well, what about the 5? What about the 5 up here? Well, we weren't trying to figure out from a certain time, like from in the year 2100 or in the year 1980. We just want to know how fast is it happening every 10 years. And so this is the rate of change, rise over run, rate of change. This is the years, and so that's why we can take the rate of change times the number of years, and that's what will give us the 0.25 million. I hope that was a satisfactory explanation.